too. Usually I get some ideas. Oh, good. Yeah, I was about to say drink water. I'm happy I see that already. I see eat. Yup. We got my work. That's good. We got some reading, doing work early, finishing homework. Yes, finish that homework. I'm glad to see it in, by the way. Props, props. Go for a walk, work and rewatch Raya and the Last Dragon. That sounds fun. That would be good. Oh, that actually makes me think I need some relax time and watch some stuff. Try to sleep early, do some more work, and I think that's sleep, maybe. Gotta eat, finish work, clean your room. Yeah, when it feels good to clean your room when it's not like forced, that's for sure. Or when you're like good on time. We got sleep early. That's me too. I'm gonna try to sleep early too. Go to eat, finish homework. Ooh, I'd like to see relaxing, meditating. Oh, for me, it's like definitely. So drink more water. To me, I think it's like what I'm putting into my body today. So I'm gonna try to eat. Like I have vegetables that I need to eat, and I haven't ate them. So I'm gonna eat some veggies. I'll try. And drink more water. I've been drinking coffee, so I definitely need to drink some more water today. That will definitely be good for me. It will be good for a lot of us. Wow, thank you all for sharing. Let me go ahead and make sure I'm marking everyone who's here. I get so engaged every time that the chat is, so alive, and it makes it hard for me to check attendance. But let me double check with y'all, please. I'm missing Bianca, Sitlali, Marco, Alicia, Dennis, and that's it. But we just got Sitlali. Welcome, Sitlali. Let me go ahead and re-say who I'm missing. I am missing Dennis. I am missing Alicia. I'm missing Marco. I am missing Bianca. If that was an error, please let me know. If not, cool. Let's just try to get our friends into class so that we can all get some beautiful, beautiful credit here this nice afternoon. All right. Awesome. Thank you so much, everyone, for sharing. And again, it's also going to encourage us to do something good for us today. All right. Let us get into today's agenda. So today we just took attendance, we did a check-in. We're going to be doing a Desmos. It's going to be an individual Desmos though. And we're going to talk about what is a radian. So perhaps that's a new word to y'all. After that, we'll have an exit question. And then lastly, a little reminder that, sorry, asynchronous number 7 is due today. That's a little reminder there. There we go. Does anyone have any questions about today's agenda or, what's due or anything like that? Please let us know. But if not, I'll just move us on. Okay, awesome. So I think we look good. Oh yay, we got more people coming in. Let me adjust this attendance here. So glad to have more of us in. All right, so we got a great opportunity for credit today. Always excited to get some credit. We're going to talk about what is a radian. So in a second, I'll give you all the Desmos. But before we start, I do want to talk a little bit about some ground stuff before we begin. So Desmos lesson, we have this learning target. I can explain what a radian is and relate a radian to degrees. So again, radian might be a new word for you, but one thing we could probably use some context clues here and kind of notice that there is some relation to degrees, so like a degree measure. So let's just go ahead and read that learning target, let it soak in, and then I'll move us on to the next slide. I'm on slide number 4, by the way, for those following along. Okay. So that's our learning target. We're just going to keep that in mind as we investigate what is a radian, how does that even relate to degrees. Before we get started, here's a little bit of things you should know. Some refreshing on some terms. So we're going to be looking at circle stuff. Y'all remember yesterday on the palette, we did a checkout and there was this new thing I showed you, something called a unit circle. Well, in order to further investigate that unit circle, let's just refresh ourselves on some vocabulary. So I'm going to start right here on the left-hand side. Here we have a circle. The outline of the circle here is called circumference. Usually that's kind of like your perimeter. You could imagine this as like kind of like wrapping a string around and you measure that length of the string. That is your circumference. Your circle always has a center. And when you draw a line from the center up to the circumference, that's called a radius. And it's also worth noting or worth mentioning that the radius is the same everywhere. If you were to draw a radius here, that's going to be the same length as this one. If you were to draw a radius here, same length and so forth, right? You just keep going around. That's why usually people use what's that called? It starts with a P. Maybe someone can help me. That thing that you draw a circle with. Y'all did it in geometry. Protractor, is that the word? I hope that's right. But yeah, let's see, is it right? Let's bring, so yeah. Okay, thank you so much, Jorge. Okay, I'm right. Yeah, okay. See how y'all are holders of knowledge? Definitely. Okay, so there's that. Here's another piece of information we might be using today. The circumference of a circle has this formula. It's 2 pi r. Maybe y'all remember calculating with this in geometry. Another thing that might come up is arc length. Usually what that is, it's like kind of like a portion of your circumference. And this portion is kind of cut apart, kind of cut like a slice by an angle measure. So this is called arc length when it's kind of, I guess the proper word is subtended by an angle is what we would say. But if that doesn't make sense, just look at the picture here. That's what an arc length is. So these are just refreshing on some terms because I'm gonna say those words. Like I'm gonna say circumference, I'll say radius, I'll say arc length, and I might say, or I might use the circumference formula. So just keep these in mind when they come up, or you could just go back to this slide number 5. Nextly, before we begin our Desmos, right? I wanna mention that I actually included the screenshots of all the Desmos slides in my slides, so that while we're talking about stuff and all of that, you could still write notes on your copy of the slides. So that's what I did here to kind of better support. If you want to take notes during the Desmos activity, you could still be on the slides taking notes as you're participating on Desmos. So that's if you desire. So I'm just leaving that option there. I just want to let you know that all the slides are there. But once that's done and over with, let me know if anyone has any questions. Other than that, let's go ahead. We're period 1, and we're going to go to student.desmos.com, and we're going to go ahead and type in this code. So let me give you all a moment there to go ahead and log in, and I'm going to join you in a second. Go ahead and get logged in. Let's take a minute. Hi, everyone. I hope we had the time to log in. I'll be completely transparent right here. I had a quick bathroom break, but I'm hoping y'all had time to log in there with my bathroom break. Yay. Okay, great. We have 18 of you in. Yes. But we still need to think about 5 more because it says we have 25 participants. So let me please let you log on. In a second, I'm going to start the pacing on this. That means it's going to kind of restrict on what slide we are, but feel free if you want to venture and see what kind of questions you're going to be asked. You're totally welcome to do that, but it's also on our slides as well. So I copied and pasted the what we're going to talk about today. We're going to do some learning today. But yeah, so let's go ahead and get logged in. We have Maria's in, Francisco's in, Juliana, Marjorie. Don't worry, I'm gonna anonymize it, but I mean, I just want to give a shout out to who's here. We got Henry, we got Aisha, Kimberly, Rogelia, Jeanette, Miles, Leslie, Dana, Jorge, Kayla, Gianni, Marvin, Niara, Ethan. That's who we have who's in. So please get yourself in. Thank you so much for being in. I see you all. Then we have, can we please have the code? Yeah, the code is usually up here, right here. Let's see, but I'm gonna also put in this in the chat. So we'll doubly get you all in. Boom. There you go. Yay, we're getting more in. I'm gonna go ahead and start to turn on the pacing just because why do I like struggle to get a hold of this there? I don't know. I always struggle with Desmos, but we got this. Or I got this. Positive thoughts, right? I'll try. Great, we're getting more of us in. We got 22. You see your name here on the screen. Awesome job. Thank you for being here with us. I always wonder, like when I screen restrict, like how is there still someone like how have you overpowered the system? Okay, I'm gonna go ahead and now start to anonymize the names so that we can begin. There we go. Here's our new names. Welcome if you just came in. I'm gonna go ahead and re-put the Desmos link in the chat. If you need to join us, there it is. Okay, everyone. So the first screen you should see is the Desmos lesson itself and our learning target once again. I can explain what a radian is and relate a radian to degrees. Cool. Let's go on to slide number 2. Now, well, before we go on to slide number 2, let me give you a little warning. Yesterday on a Padlet, I had you guys do notice and wonder on a unit circle, but actually what I showed you was a partial unit circle. Let me show you the full one. This is slide number 2, everyone. Don't be scared. Oh, wow. What? Wait. Are you all already started on this? Oh, impressive. Impressive. Okay, so I moved everyone to slide number 2. We already have some contributions here. Yo, wow, are amazing. But what we're doing now is I am showing you the actual filled out unit circle. Look at the different colors, right? And then sorry if it's just distracting, but let me go to student mode. There we go. Look at the different colors. Look at the different things coming up. This is the fully complete unit circle. I do now want you to put a notice or wonder about this one. So this is actually the complete unit circle. It's not like exactly like the one I showed you on the Padlet. I didn't want to scare you too soon about by showing you the filled out unit circle, but don't be scared. We're gonna break this up, together. So go ahead and put a notice or wonder here. I'm gonna let everyone finish up so that we all have time. Because I think some of you had a head start. So let me give a few more seconds here. And we'll come together and take a look at what we got. All right, everyone, we're coming back. So please make sure that you put your contribution there on the second slide. Wow. So these are really, really great notices and wondering. So a lot of you are noticing there's these fractions and degrees all around at different points. So that's something that we're noticing. And then when you all say fractions, I'm wondering if you're talking about these here or you're also talking about these in red. So that's my wonder when I'm looking at when you're noticing these fractions. Um, there's some division among four sides. You notice there's angles, so there's these degree measure of angles. And then I wonder what the fractions outside of the circle mean. So I'm guessing they're talking about these outside of the circle. Okay, so the fractions with the square roots, those are again those numbers in parentheses. Um, and then there's degrees. I like this one. I noticed that the degrees of a circle from 0 to a full 360. Y'all see that? So when you start from 0 degrees, go around and do a full circle like so, we do end up at 360 degrees, right? So a full circle is indeed 360 degrees. And again, oh, somebody's noticing those red fractions that have a pi in them. Yes. I know my circles look really crooked, but yes. Awesome. We're going to talk about these things. These are great notice and wonders. Someone else said something that I really wanted to point out. We are wondering what they represent. And is there another way to solve it? I like this one I wanted to highlight. I wish I could highlight. This isn't Padlet, but I wonder if all the three different colors equal to each other. So like, are they all equivalent? Like when they're written like that. I love that. So there's noticing about those fractions that are in red, the pi. Ooh, here's the last thing I'm going to point out. Again, I wish I could point out all of this, but I'm trying my best to point out like the parts that are going to lead us into the next thing. So Blaze here said, I noticed that 2 pi is equal to 360. So let's investigate that. I'm going to go up. So notice that 2 pi is equal to 360. Is that correct? So according to Blaze, they're seeing these as two equivalent things, that 360 degrees is equal to this thing in red, 2 pi, right? So that's that was a notice. Now, I'm going to say this to those wonderings. Yes, these are equivalent. So first off, these are equivalent measurements. So 90 degrees is going to be equal to something called pi over 2 radians. 120 degrees, it's equal to 2 pi over 3 radians. So that's what we're going to learn today. That stuff that's written in red. It's called a radian measure. Wow. So it's awesome that your thoughts were already leading us there. So awesome job, y'all. Let's go ahead and go to the next slide to kind of learn a little bit. Let me go back up to my pacing. We are on slide 3. All right, everyone. So let's talk about this. Sometimes when we talk about rotations, right, we like to describe things in degrees, like 0 degrees, 90 degrees, 180, or for example, if you're doing a 360 in skateboarding or walking, or sometimes people use, do they use, now y'all can correct me if I'm wrong, what is it when someone changes their mind and someone says they did a complete, was it 180 or 360 that they say? Let's see what's in the chat. I don't know. I know I hear people say it. It's a 180. So for them, it's kind of like, for me, I would say they did a whole 360, but 180, I think makes sense because 180 is like flat. So it's kind of like they were on this side, but now they're on this side. So it makes sense. So they did a complete 180. It's like they're using degrees. Yeah, to kind of describe even like a situation. So it's like we're so used to talking about degree measurement, even in our casual conversations, like someone doing a 180. So, okay, cool. So we're used to degree measures. Today we will learn a different way to describe rotation or angle other than degrees. And this new thing is called a radian. And I love that. Thank you for putting that sentence in there, Francisco. That helps kind of describe it, put it into context. Thank you. He changed his life 180 degrees. Awesome. Okay, so then maybe some of you are thinking, well, if we're so used to and comfortable to degrees, why can't we just stick to it? Why does that unit circle have to even have that? Let's talk about that first. So we're going to go to slide number 4. I don't know how there's still people in these other slides. I do not know how that works, but let's join us in slide number 4. But why radian measure? What's wrong with just using degrees? Why can't we just stick to it? We love it. It's so easy. So the radian measure relates more actually to the radius length of a circle. That's where its name kind of comes from. So radian kind of sounds like radius. It relates to the radius length of a circle. So for example, radians are going to help us in this case. Let's think of something like 45 degrees. I tried my best to make this angle look like 45 degrees. But let's just imagine there's an angle that's 45 degrees. And let's say that I want to describe the distance that like some rolling wheel is covering. And let me just draw in this rolling circle. Let's just pretend this rolling circle rolled about, that looks more than 45 degrees. Well, let's see. Let's just pretend 45 is like right here. Let's just say that this is about rolling of 45 degrees or something. Say 45. And then in that 45-degree roll, it probably covered like this much of a distance. And I want to say, it wouldn't make sense to say that the ball rolled 45 degrees. It wouldn't make sense because how can we measure 45 degrees on the ground? That's one thing to think about. So this is why we need the angle measure to be represented in radians, because that's going to relate to the radius length of the circle. It's going to actually be able to provide us a distance that we can measure. So if my radius length is like in inches, if I know that the radius is in inches, the radian is going to give me a measure that will help me in inches. So we're able to kind of record the distance a rolling wheel covers if we kind of switch to radian. So that's kind of like the why. Again, the radian measure relates more to the radius length of a circle. Let me know if anyone has questions on that, but that's the why are we trying to use radians now. But we're still using degrees. We're just adding in radians. And a degree measure is going to have an equivalent radian measure. Okay, that's all in good. Now let's go ahead and define, well, what is a radian exactly? How do we figure that out? Let's all go ahead and transition to slide number 5. And don't worry, we're almost going to have time where you all put your thoughts down so that I could get a feel of where everyone's at. Okay, now for the moment, I want you to kind of ignore these 2 boxes or these 2 photos. And let's focus on this one here. It's like on Desmos, it's kind of like not a slide. So it's hard for me to pop up things, but let's focus on this one. So I'm going to describe to you what a radian is with these visuals. Okay, step 1. Let's say you have a circle. You go ahead and you draw your center of your circle, and we just call that O. You could think of that like origin or something. And then you go ahead and you draw a radius inside your circle. We call that radius R. So that's step 1. Let's think of that as step 1 into determining what is a radian. So 1. Okay, sounds good. If we got that, awesome. We just drew a circle, we drew a radius, we called that R. Whatever R is, R could be anything, could be any length. Okay, now step 2. This is what we do next, everyone. Imagine that you take this radius length R, right? Let's say you take it, you color it in red. Let's say you take this length and you're going to drape it along right here. You're going to start to drape it where this line intersects the circumference. And I'm just going to drape it or just drop it down there. And it's going to curve. Kind of think of it like this length is like a string, and I'm curving it on the circumference. Because I just basically took this length and I draped it up here, right? This red line right here. That's just going to have the same length measure as R. So that's step 2. And I'm just trying to see if there's questions. Unmute or use the chat, either one. So that's step 2. I took my radius and I draped it along there on the circumference in red. And I'm just noting that this is the same measure. It's called R, and it's the same measure as my radius. Okay. Now let's see what happened in step 3. Step 3 is all I had to do was where my radius length kind of ended, I went ahead and I drew a segment down back to the center. And when I draw this segment, right, let me change my color. When I draw my segment back down to the center of the circle right here, it's going to be measured as length R, because remember everyone, no matter where you draw a line from the center to your circumference, they're all going to be the same length R because it's a circle. So that means if I was to draw this line down here, this has to measure also R. So that's what I did next. And what I virtually did to kind of go back to our definitions is I created an arc length. Remember that definition on our slide? And if you don't, let me just show you. Definitions, boom. What I did is I created an arc length, but I created it using the radius of the circle and draping it along the circumference. And I created an arc length is what I just did right now. So I'm going back, using that vocabulary. So that is what I just did right here. I created an arc length. Now, what is the measure of this angle? Let me tell you all. The measure of this angle is going to be 1 radian. That is the definition. 1 radian. That is how we come up with a radian right there. We'll go ahead and take a moment to process what we just did. So this measure right here, it is 1 radian. Again, take a look at what we just did. We took the radius measure, we draped it along the circumference. We drew back another radius length down to the center. And whatever that angle is, right, that angle that we made when we created that arc length, that is called 1 radian. So that is how we define 1 radian. And we're going to see how that's related to degrees, or how we can even convert from degrees to radians in a bit. But I just want to make sure that we're okay with this process. And we'll have some time for questions as well, but feel free to ask them in the chat. Okay. And again, feel free to be taking notes on the slide for anything that was mentioned. Okay, now question 6, everyone, is going to involve some participation right here. So let's go on to slide 6. Dang, Pierre. How did Pierre already get an answer? Okay, so now that you're on this slide, right, we're going to go ahead and now investigate. So how many radius lengths do you think, like how many of these segments do you think it'll take to kind of cover this full circle circumference? Go ahead and try to measure with your fingers, just do that. Try and guess to see how many. You can't be right or wrong here. Just let us know what you think. Go ahead and take a minute for this slide. How many radiuses are going to fit this circumference all the way around? And let me know if anyone needs me to clarify that question. So like imagine that we're taking this length and we're just like drawing it again and again until we complete the full circumference. Can you rephrase it? Yeah, and I'm hoping this visual helped. Let me just undo that. So how many radius lengths will cover the whole circumference of the circle? Or how many of these, right, these lines or these curves in red, can I repeat all along the circle until I cover the full circumference length? Is another way to kind of phrase it. And let's see if anyone else is interested to help us continually rephrase that, if there's another way. Let me also do this. So let's say I measure that this is I don't know, I'm just gonna eyeball this, that this is about that length. So I'm just gonna go ahead and measure about that length. Like, okay, here's a second radius. Let's say I think it's about that much. And then I keep going like, okay, let me make a third one. And I'm gonna kind of approximate that radius length. It's about, so far it looks like 3. And then you're just gonna keep going until how many radius lengths? So right here it's 1, 2, 3 so far, but how many will it take to do the full circle approximately? So I hope that helped as well. Let me give you all a moment for everyone to answer. I mean, if you're done already, awesome. We're gonna take a look at what the precise answer would be in a second. All right, everyone, please make sure to go ahead and put your best guess. So here are the different answers we're getting. Just to tell you, when I tried this using my hands, I'm really bad with measurements and my hands move when I do that. So I don't know why I keep doing that. But anyways, I got 5. That's what I got when I used my hands. So I see 5 or 6. I'm seeing 6 come up a lot, 6.5. We got some reasoning. Ooh, look at this mathematical reasoning. So this one says it looks to be around 8 because it looks like it's a 45-degree angle. Oh, whoa. So they're saying like 45 degrees and they're using that. Oh my goodness. It's amazing reasoning right there. 5 or 6. We got about 6 and 5-ish. All right. That seems pretty much like everyone's in agreement. The 8 was the only one that was a little different, but I love that reasoning. Like 45 degrees and how many 45 degrees in a circle. But all right, y'all, ready for the answer? How much was it? Wait, let's see what's in the chat. Yes. By the way, there's a question. Is this activity a participation grade? Yes, yes, yes. You cannot be wrong. Just go ahead and put your thoughts in the chat. Yeah, you will get participation for this, definitely. Okay, everyone. So as long as you're like, when I unanonymize, I'm able to see everyone's name and give you credit, which I'll do right after. I also gave everyone credit for the Padlet yesterday. If you didn't get a credit, you should have got an email though, I believe. But anyways, let's go ahead and see what's the answer. Dun, dun, dun. So let's see, I got 1, 2, 3, 4, 5, 6. And then there's a little bit left over. Y'all see that? So we have 1, 2, 3, 4, 5, 6, but then there's still a little bit left over. I know some of you are perhaps reading this. I'm gonna go ahead and explain its connection to that circumference of a circle formula. So let me just rewrite it down here. So feel free, if this makes sense, awesome. You could read that. I'm gonna just go ahead and re-explain it right at the bottom. So we know that a circumference of a circle formula, as I showed you in the beginning, is 2 pi r. But remember, our r is basically our radian. So let me just go ahead and type radian. Okay, cool. So then that means, what that therefore means is that it's going to take 2 pi radians to fill the circumference of a circle. And some of you remember what pi means, but if you don't, pi is about, and let me just underline that, pi is about 3.14. So if 2 pi radians is my circumference of my circle, let's go ahead and try to figure out what 2 pi is. all we got to do is do 2 times 3.14 because that's what pi is, 3.14. It's actually more than 3.14. You know, it's 3.14 and blah, 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 blah. There's like more, it keeps going. Let's just round it to 3.14, multiply by 2. I'm using my phone. I got 6.28. So about 6.28 radiuses cover the circumference of this circle. So 6.28. And I also put the formal way to say radiuses. It's radii. It just sounds weird to say radii, but that is the formal way. 6.28 radii cover the circumference of the circle. Radii is the plural for radiuses. That's the proper way. You shouldn't say radiuses. Don't say that in college. Yeah, so a lot of you were close. And then 3.14 and a bunch of decimals, yes. I mean, there's people who know it to like a lot, but I'm like, I mean, I don't know what would be the worth of memorizing it, but hey, if that brings them joy, awesome. But yeah, it's a very long, it just keeps going forever and ever. But I hope that makes sense. So most of you guessed around 6, right? And it makes sense if you actually make a connection with the formula of the circumference of a circle. There is about 2 pi radiuses that cover the circumference of the circle, 2 pi radii. And if you were to actually multiply that out, it's about 6.28 radii that cover the circumference of the circle. Yes, so let me know if anyone has questions about that. Again, we were all so close. I mean, I got 5, but still close. Okay, awesome. Let me go ahead and clear these drawings. Now, we're going to go ahead and now investigate, well, what is now the connection between radius and degree? Someone mentioned it already. That's why I circled it earlier. Ooh, I forgot who it was. Feel free to like give yourself a shout out in the chat. But let's move on to slide 18, everyone. Someone said that, remember at the beginning, when we were looking at notice and wonder, somebody said that 360 was equal to 2 pi. So someone said that is equal to 2 pi. I can't type out the actual pi symbol, so I'm just using pi. So that was something someone said. That's exactly precisely what we're going to use to convert between radians and degrees, everyone. 360 degrees, if you go around a full circle, that is 360 degrees. Also, if you go around a whole circle, that is 2 pi radians that covers the full circle. Therefore, these two measures are equivalent. That is correct. Well, what do we do with that then? So what we have is, let me rewrite it down here. Let's rewrite this in math language. If these are equivalent, that means 2 pi radians is going to equal 360 degrees. That's what it means in math language. Okay, so we have this equivalency. Awesome. I'm going to now try to simplify this equivalent expression to something nicer. Let us divide by 2, both sides. If you do it on one side, you got to do it in the other. 2 divided by 2 is simply 1, or you could think of that as canceling out. And then we're going to do 360 degrees divided by 2. Let me know if anyone has the answer to that. What's 360 divided by 2? Maybe in the chat, or you can unmute. We've got 180. Perfect. Thank you. So to the 3 of you for saying 180. I see you. Thank you for your engagement. That is right. That is equal to 180. And then we have degrees. So pi radians is equal to 180 degrees. We're going to be using this to convert between degrees and radians. How that's going to look like is we're going to use either, and I'm going to write it, let me write it over here. We're going to use either this expression, pi over 180 degrees, or we're going to use 180 over pi. And why do these work? First off, I want to remind you all, these 180 degrees is equivalent to pi. That's what this equality symbol means. That means this represents a unit of 1, because 180 divided by pi, if they're equivalent, that means they represent 1. Like anything divided by itself is 1. So we're going to use these to convert. So these are the formulas, first off. So feel free to write this in your slide or something, or to, take a photo. I think I do have it on the slides though, just so you know, it's on there. But this is what we're going to use, and that comes from this truth. And again, I love that someone mentioned it already. So it's not like we're making it up or anything. 360 was equal to 2 pi. And from that, we were able to divide both sides by 2 to get something nicer and easier, that we have pi is equal to 180 degrees. And we're going to use that to kind of create an expression or two expressions to convert between radians and degrees. So we're going to use that soon. Let's see if anyone has questions. All right, maybe y'all are eager to see how it's used. Let me go ahead and clear my drawings, and let's go to slide 9. Okay, on slide number 9 is our next participation check. Again, there's somehow people still stuck on the other slides. I don't know how that's possible, but okay. Y'all are beating the system. Okay, we're gonna, in a second, think about how do we convert from radians and degrees, or convert between the two, I should say. How do we convert between radians and degrees? But what I want you to actually answer here is, what is an important piece of information from the slide? Like, to you, what was the most important part? This I just did, right? We had that this was equal to that, we did this, and we have these formulas. What was something that was important that I just talked about? Go ahead and put your contribution there into the slide number 9. And this is just a little checkpoint to see like what we're grasping here at this point. Oh wow, this is awesome. So I love the different variety of what like stood out as important to everyone. Awesome that Blaze over here knows how to put in a pi symbol. That's awesome. Great. And the most common theme I'm seeing here is that pi being equal to 180. Another common theme is 2 pi being equal to 360 degrees. Someone mentioned something about it being used to cancel out something. Now, where did that go? Oh, there we go. An important piece of the slide would be how 2 pi can be used to cross cancel to get pi. Oh, like what we did, dividing by 2 both sides. I agree. That's awesome. And how a circle can be broken up into sections, and we can make those equivalent expressions. Wow. Yay, Francisco showing that pi. Wait, can I do it? No. I don't know how you guys can do that. How do you do that? Oh, well. Option P. Option P. Wow, thank you. But mine looks like a square. Thank you. Wow, that's cool. I got it. Thanks, Francisco. Wow. I'm always learning something new from everyone, not just in like politics. And Cisco also got some skills with the keyboard. Awesome. All right, cool. So now everyone, what we're gonna do is take a look. Well, how do we use those two things that I just said, the formula, to actually convert from radians to degrees and vice versa? What I have for you is a video recording. So the reason I'm doing this is because I can't put my slides in here. So I just decided to record myself doing it, the examples. And we're gonna look at these examples. And as you're looking at the examples that I'm doing, you're gonna have the option, see in your view, you have the option to go ahead and put any clarifying questions in the chat. And it looks like we're gonna stop here on slide 10. We're gonna have to do the U tries, I believe, in our next class, so we can make sure that we get some practice in. But let's go ahead and I'm gonna project this video and we're gonna watch it, and you're gonna start to put any questions that are coming up for you. Again, this is me, so it's not like I just put a con thing in here. Okay. Hey everyone, so we're gonna talk about how to convert from degrees to radians and then vice versa. I'm gonna go ahead and pull up some slides and let's go ahead and talk about this. So here we go. We'll go back a bit. So we're going to talk about an example where we need to convert from degrees into radians. And as you can see over here, we have two different equivalent expressions that we can use to go ahead and convert. Now, I noticed that for one, we have pi radians on the numerator position, degrees in the denominator. Or the other setup, we have the 180 degrees in the numerator, and then we have the radians in the denominator position. So we need to decide which to use when we're converting. And it helps to just take a look here that we're converting degrees into radians. That means that degrees needs to cancel out. So we're going to look at these expressions and see which one of these is going to help us cancel out degrees. Well, here's our setup, y'all. So notice how the 60 degrees is going to get multiplied by the expression. And when we do this multiplication, these degree symbols, notice I did convert the degrees into a symbol. These degree symbols will cancel out, and we're going to be left over with just radians. So let me just go ahead and show you this. So this is going to cancel out, and we're going to be left over with just radians. So let's go ahead and see. So notice how I did 60 pi, that's on top, divided by 180. But you also notice that instead of 60 and 180, I just wrote 6 pi over 18. The reason for that is because I know that 10 goes both into 60 and 180. So all I simply had to do is kind of just cancel out these zeros, because I'm basically kind of canceling out the 10 that was in common between the two. You could have just multiplied these out directly and then simplified that. But yeah, so now we're going to go ahead and further simplify this. Notice how we're now in radians. So we've already converted from degrees to radians, but we now need to simplify the expression. So in order to simplify this further, let's think of common multiples between 6 and 18. So I know that 18 is going to be 6 times 3. So immediately we can, cancel out that 6. And we're going to get its fully simplified form. Our answer is going to just be pi over 3 radians for this question A. Let me just clear my screen, circle the clear answer so that you all understand what it is and why. Boom. Okay, not only that, you're going to also be asked to convert from radians to degrees. So we first off used this first one. We use this first one here. And now we're going to transition into using this. So going from radians into degrees, we're going to use the second expression. So let me go ahead and go back and okay. So that's going to be B. Convert pi over 6 radians into degrees. So we're going to be using that second one right there. So I'm going to take pi over 6 radians and I'm going to multiply by 180 over pi radians. And we're going to try to simplify and cancel out some stuff. Immediately, radians cancel out. Nice. And y'all, pi cancels out. That's very nice. So I'm just left over with 180 degrees divided by 6. That's nice. We just got to use a calculator. Or you could simplify this if you want to. You could do 18 times 10 at the top and cancel out the 6. But y'all, if you just use your phone, just do 180 divided by 6. You should get 30 degrees here. And that's how we convert from radians to degrees. Here are our 2 separate examples. Make sure you take a moment to, create some questions for your teacher. For me, if you have it. All right. Oops. Hello, everyone. Welcome back. Welcome back. Sorry, let me go back to the Desmos because I made this full screen. Okay, great. Let me just go ahead and check out what questions were coming up. Oh, okay. Or if you didn't put it in yet, go ahead and put any questions that came up for you on slide number 10. And what we'll do is we'll use this as our checkout today. So this is going to be our checkout today, and then we could come back to any questions that are coming up. And what's going to happen in our next class period is we're going to go ahead and try to get some practice in doing our own conversions between radians and degrees. But yeah, go ahead and fill out any questions. If none, that's awesome. But if you do have some, please let us know. Don't worry, you'll be anonymous. Okay, so I see 2 different questions. So why are radians equal to 180 degrees? For that one, it came from the previous slides, but I'm happy to also kind of review that the next time we meet up, of course. And how can switching, I think when you're saying, when Dorothy says switching, I think they mean like those 2 different equations we had, like which one to use. How can they be different or similar? And then so far, no other questions. All right, do make sure you enter in your last thing, everyone. We're gonna go ahead and finish this next time. Y'all have a great day. Bye, everyone. See you soon. Enjoy. Bye. Bye, y'all.